Hi, this is Steve Hargadon, and welcome to the Future of Education. It's Thursday, the 16th of August, 2012, and our special guest is Paulo Blikstein. Paulo, welcome. So glad to have you here.
Thank you, Steve. Thanks for inviting me, and it's really glad to be here to share some thoughts with your incredible audience.
Well, they're very excited to have you here. You and I actually met, I don't know if you're going to remember, at Maker Faire, but I was, I think, dashing out at the moment you were giving your talk. So this is my way of following up and making sure I get to hear more from you. So thanks for being here. The Future of Education is a Web 2.0.
I do remember that, and you asked great questions at Maker Faire, which is great.
Oh, I'm glad. Future of Education is a Web 2.0 Labs project. Thanks to Mighty Bell and Blackboard Collaborate for support. Yeah, that was really fun at Maker Faire. Thanks to all those who were there and participated, and especially to Betsy Corcoran from EdSearch. Coming up next week is our Learning 2.0 Virtual Worldwide Conference. If you don't know about this, please go to learning20.com and check it out. An unbelievable lineup of keynote speakers. And we're making up for any gender inequality there's ever been in EdTech keynote speakers, because it's about 3 to 1 female to male, but really fantastic. Plus, you can still submit to present. The first day is going to be an all-day unconference. This is a complete experiment. Social EdCon online. Check it out at learning20.com. It should be really fun. I know it's a hard time of year. Everybody's busy. But for what you're able to attend, please feel free to come. And then 4 days after that, Tuesday through Friday, of just amazing presenters and keynoters. This is all part of Connected Educator Month, connectededucatormonth.org. Things going on every day, just amazing things, and we're so appreciative of that program. Future of Libraries Conference, also worldwide free, 2 days coming up in October. Really good speakers for that as well. And then, of course, the Global Education Conference, November 12th to 16th, the just incredible global gathering. Hundreds of presentations, just a blast. Hope you can join us for one of those. If you have missed, coming up on Future of Education, today is Paulo. I see every typo, of course, the moment I pull the slide up. Right, Social EdCon on the 20th, David Warlick, Mark Prinsky, Michelle Pacansky-Brock, Lucy Gray, Rob Freed, Heidi Hayes Jacobs, Lee Rainey, Esther Wasiski, Gina Bianchini, Yong Zhao, Angela Myers, Audrey Waters, Cheryl Nussbaum Beach, Sugata Mitra, all keynoting next week at Learning 2.0, plus all of the other interviews coming up. Hopefully something there that's of interest to you. We really appreciate it when you do take the time and come, and hopefully these are valuable for you. If you've missed any shows, they're all recorded in full Blackboard Collaborate form and in MP3. Stephen Downs, Howard Gardner, Alfie Cohen, and Gary Steger talked about reforming education reform last week. Oh, that's so worth listening to if you missed it. Connie Yowell, before then, Larry Johnson, Doug Rushkoff, Chris Lehman, Deborah Meyer. These were all keynoters from the kickoff session for Connected Educator Month. Again, everything's up at futureofeducation.com with good quick links there. So this is where you get to tell us where you're participating from. To the left of the map, you should see a star icon. It's the second one down. You click on that twice, and then you can click on the map. And as I mentioned, today's a unique day. I'm at my mom's nursing home, streaming through my cell phone's 3G connection. And I just love technology. Really delighted to have you here. Wherever you're from, please feel free to put a shout out in the chat. I will put that I'm in hot Sacramento. California. Some New Zealanders, Australia, Wherever you are participating from, we're sure glad to have you here. We appreciate you taking the time. And if you're listening to the recording, thanks for doing so. Okay, I'm going to move us forward here. Feel free to keep those locations coming in the chat. There is a Mighty Bell space for this session, and I will put the link in the chat for you. Mighty Bell is the new program from Gina Bianchini. She was the creator of Ning, and I'm consulting for her on this new project called Mighty Bell. I just love Mighty Bell. Again, that has to be understood as coming from somebody who's getting hired to do work for her, but I do really like the concept. It's like Pinterest with conversation, so curation plus conversation. And if you go to that link, you can join up. I put some of Paulo's web links there and a video from a TEDx talk that he gave, and feel free to gather other resources there from tonight's interview. Paulo, so you and I met at Maker Faire. That was a great event, and I was really sort of delighted to get acquainted with you. Why don't you tell us a little bit about the path that has brought you here into Stanford, and then we'll kind of look at the passions that drive you, and then in particular the Fab Lab program, and we'll talk about the low-income populations as well. So how did you get to where you are now?
Well, I think first of all, I had a very important experience when I was a child. My parents enrolled me in a school, in an elementary and middle school, that was run by the daughter of a very famous Brazilian educator called Paulo. So this guy in the 60s, he started saying things that people would, take as this guy's totally crazy. But he said, education should not be standardized. It should be culturally adaptive. It should be meaningful for students. Students should be empowered in the classroom. They shouldn't be oppressed. They should learn about things they care about, and all kinds of things like that. And then, of course, in the 60s, this was like, crazy, but now it's like what everybody is talking about. But he started this in the 60s, and his daughter actually opened a school in São Paulo in Brazil, and then my parents enrolled me in this school, and I was there for 8 years until I went to high school, and that was a very important experience for me, because we didn't have exams, we didn't have grades, we didn't have textbooks. And then, so I learned about learning in a very special way, in a very different way. So for me, up to that point, learning was a pleasure. Learning was something you do because it's enjoyable. And even when it's hard and it's a lot of work, it's never an imposition from, some authority that you really don't, and you don't know what's going on. So I think that is really at the root of the kinds of things I believe in and the kinds of things I do today. And then, let's fast forward to when I finished undergrad. I did engineering as an undergrad. And then when I was finishing, I started thinking, maybe there are people in the world thinking about how education can be different, how it can be more like the experience I had in the Freire School. And then I was kind of randomly looking through my books and my bookcase, and I found this book that my uncle had given me when I turned 15, and the book, it is called Mindstorms, and a book written by Seymour Papert that, and I started rereading it, and I said, oh my God, this is exactly the kinds of things I like, I believe in. And I started looking for where is this guy in the world, Seymour Papert, and I found out that he was teaching at MIT and had a research group at MIT Media Lab. So, in a crazily optimistic move, I sent an application, and I got accepted to work at the Media Lab. I spent 3 years there, and it was like wonderful years of really eye-opening experience. We worked in Senegal, in Brazil, in Mexico, in Costa Rica, and all kinds of environments and countries. And then after that, I realized that I knew where I want, the end game. I think I knew what I wanted, but I needed more tools. I needed more rigorous research methods. I needed to convince more people that, this is an interesting approach. And I thought that a good approach would be to be an insider, so to go to a school of education and do a PhD and actually, acquire all the tools that researchers in education have, so that I can make a better point of why, those kinds of more open-ended, student-centered environments are better. So not just, people should believe my word or they should believe my anecdotes, but they should believe my research. And if they say no, this is insane, they should then do a large-scale experiment, like some of the things I'm doing. And so I think it changes the debate. I think we have a lot of people that are advocates of traditional education just on the basis that we've been doing this for 20 years or hundreds of years, and that's that's the best way of doing it, or on the basis that, look, we have all this body of research, this kind of hardcore quantitative research saying that this is the best way to teach math. So I think we have to, at some point, start talking that kind of language as well, to convince those people that that's not the best way. So anyways, I did a PhD in education at Northwestern, and then I came to Stanford 3 years ago. And then that's how it kind of connects to the Fab Lab. Of course, at MIT, I was in the lab every day, every night. And I said, this is an amazing place, and this should be in every school. And then when I came to Stanford, I had in the whole job negotiation process, I said, I will come here if you build me a Fab Lab. And they said, this is crazy. In schools of education, we just read and write books. We don't do anything with our hands. This is not the place for a lab like this. And then I said, well, okay, so I'll go somewhere else. And it was really a revolutionary thing, because now, so this was the first school to have a the first school of education to have a full fabrication lab. And people come, they enter the school building, the Stanford School of Education. They come to the lab, and they say, "Is this like misplaced in the university? I mean, why do you have a lab in a school of education?" And then 5 minutes later, they want to explain what happens. That kids, they come to the lab, they build projects, they do all kinds of things. They say, well, that makes a lot of sense. Why doesn't every school has a lab so that we can train teachers to, do this in the schools and all of that? But so that's a quick overview. But I'll let you ask all the questions. How more I can talk more detail about the lab and how we're taking this to other schools and all of that.
That's a terrific intro, and I did not know about the Freire School, which is fascinating. So you have this combination of Freire and Papert, and sort of uniquely position you to be able to discuss those pedagogies at a place as prominent as Stanford. How do your colleagues respond? I mean, if you had to kind of give an overview of the Stanford School of Education, when they agreed to build the Fab Lab, do you feel like there's a general understanding of its value, or are you still trying to convince other faculty members of the importance of this?
Well, I think, I have to say that I think my colleagues were incredibly supportive, and they really took a risk, because, it's not just building the lab, but, when you put resources into something, people always question, why not do something else with that money, right? So I think, the leadership at the school, Deborah Stipek was the dean at the time. She was very, I think, brave to do that. I think, in the beginning, people were a little, what is this thing? Is this like this engineering guy doing some kind of gadgets? What does this have to do with learning? And then it was interesting, because I invited some of the kids of the faculty to come to the lab, and then the kids would come and their parents would come. There's professors at Stanford, and then through the eyes of their kids, they would, immediately understand what it was all about. So, the kids were, suddenly like laser cutting and 3D printing, like these 12-year-olds, 3D printing, laser cutting, and then the parents who were, previously skeptical would say, oh, you could tell that they really understood because they saw it through their kids, and then they see what, it can do to other kids, to other students in other schools. So I think that was an interesting way that it happened. But also, especially I think the main way is that we are, publishing and doing rigorous research in those kinds of environments, and I think that's a language that everyone in academia understands. So I think that's another way that it's happening. I mean, when they go there, it's not just, they don't see just kids making stuff and playing with machines, but they see, we have a ton of panoramic cameras capturing data all the time. We have microphone arrays capturing their speech all the time. We do all kinds of, things with computer vision to detect how people collaborate. We have eye trackers. We have, skin conductivity. I mean, we do a lot of, so they see that it's not just a place for, playing, but it's also a place for research. But I think that story was very interesting to see how it's changed. And now it's funny that every visitor that comes to the Stanford School of Education, they take them to the lab first because, it's like there's no lab like this in other places. So they say, look, we are so cutting edge, come see the kinds of things we do. So it was an interesting kind of change of.
I think you must have turned your mic off. So
no, I stopped talking.
Oh, good. So I put up the website. Well, I think this is this the correct website for the lab?
Yes.
So there have been some questions in the chat about what actually takes place in a lab. You've described some of it. How do you describe what takes place in a lab? Is it structured, unstructured, and who's actually coming and using the lab?
Yeah. So the project that we started is called Fab Lab at School, which is a special branch of the fabrication lab that happens in schools and for kids and for learning, right? So we call it Fab Lab at School. So the interesting story that happened and in the very beginning is that we brought kids to the lab, and then they started, they came the first day and they started exploring the machine. So we had the first activity was to build a keychain, right? So they built a keychain and then wrote their name on this laser cut keychain, and they took them home, and they were very excited because the things, they look very professional, this acrylic keychains. And then next day they came back, and then we said, okay, now let's do robotics. And the kids said, no, we want to do some more keychains for our parents because they really like the keychains and all that. So third day, they came back. We said, okay, now we're going to do something else. And they said, no, now we want to do keychains for the principal of the school and our friends and all of that. And then, so we spent a whole week doing keychains, and at some point we realized that there was something wrong. And what was wrong is that, in a way, the kids, they cracked digital fabrication. They realized, oh, this is a way to get these really nice products with very low effort. And that's, of course, exactly the wrong way to go about it. But the kids are, of course, very smart, so they realized that. So we realized, our first big lesson was that this idea that you just let kids loose in a lab and magic will happen, it works very well for the Silicon Valley kids who have engineers at Google that, help them do all kinds of stuff, or a lot of the kind of Maker Faire stars, kids. But for the great majority of kids, they need a lot of support and help to do their projects. And I think that's one of my worries, is that we get carried away a little bit with what we see in the media, which is always the outlier kids that were thrown in a lab and then built a flying helicopter or something. And I think that's a very important thing. I mean, we need to know that the average kid is not the one with a Google and engineer as parents or whatever, and they need help. Otherwise, what happens in a lot of what happened in my lab in the beginning, and what I see in many places, is that kids, they just do the same trivial, very simple project over and over and over again, and then they never go deep, they never really get challenged and all of that. And so I think this is one of the key things, is that you have to challenge them to learn more complex things, to build more complex things. And that's a skill that we don't teach our teachers in any teacher training program. We teach them how to manage classrooms, how to deliver the content and all of that. But when we have teachers in this kind of project-based environments, and their job description is help kids create complex and interesting projects, they don't know how to do it, because it's actually not easy. So I think that's one point that I wanted to make. But just for you to have an idea, what happens in those fabrication labs, for the most part, is that we create some generative teams. For example, let's improve the city, let's improve your neighborhood, let's improve water quality or something like that. And then the kids design projects and design solutions for those, and they don't design problems, sorry. They design solutions for the problems, and using the digital fabrication machines. And then now one thing that we're going to start doing is, now that we have a network of labs in 4 countries, we want them to also work together and collaborate on those projects. So it's normally projects like this. We started doing a lot of projects that are within the curriculum. So a project within the history class, within the math class, and all of that. So those are more connected to the content and not so open-ended, and those have been very successful as well.
So how much of, thank you. So how much of this do you think is kind of a resurgence of the shop class value, or are the two related?
Yeah, so I think, first of all, one thing that I think is very interesting, very important to say, is that, I see a lot of people talking now about, hands-on learning and digital fabrication or the maker's culture, but we have to remember that this maps all back to Seymour Papert, to that intellectual tradition of constructivism, constructionism, and all of that. And in the 60s and 70s, Seymour was doing like robotics with kids, was doing programming with kids, and sometimes people tend to forget that this is not necessarily a new idea conceptually. Of course, we're always improving it, and the issue there is that there are lots of interesting lessons and theoretical advances that were made in the 80s, in the 70s, at different places, when we had a lot less resources, but a lot of the same ideas that people sometimes ignore today. They just forget that we've been doing programming with kids for 30 years and robotics for 30 years and all of that. So a lot of this thing, we have to remember that there was a history to all of that. And so that's one thing. But sorry, but I think I forgot one half of your question. So.
No, it's fine. There's a book called Shop Classes Soul Craft.
The shop class. Oh, sorry. Yeah, sure. Okay, the shop class. So I think the issue with the shop class is that it used to be, if you're not doing well in math, they would say, why don't you do shop class? I mean, not for all students, but there is this, terrible dichotomy between, hand labor and kind of physical things are bad and are for the low wage, low income people, or low wages, jobs of low wages, and then the intellectual work, the math, the higher level skills are for the high wage jobs and all of that. And we have a lot of this baggage. So what happened in many places with the shop class is that it became the place for the students who couldn't do any math, any of the real, quote, real content, and that's a terrible thing. So what I think is exciting about the fabrication lab, the digital fabrication lab, and people ask, why do you need a laser cutter? Why not just use scissors, right? So one of the exciting and important things about this is that the status, so when you're working in a digital fabrication lab, it is mathematically not less complex than actual theoretical math, because you have to do a lot of complicated calculations to design and build your things. You have to do 3D design and all of that. But it's not just that it's interesting work mathematically, but people's perception of a fabrication lab is not the same as a shop class. So when we have kids go to the fabrication lab, it's not the low achieving students that get sent there. It's actually sometimes quite the opposite. So I think what's exciting about this is that this is a place where kids can use their hands, they can build things, they can make things, they can use a lot of math and all of that, but it's not seen by society as a place for the losers, the low achieving kids, the dumb kids. I mean, put quotes on all of those words. Of course, those are like how people say, not. And so I think that's exciting because it's an opportunity to get kids who would not normally connect with traditional content in the traditional ways we teach them, and offer them a socially valued way to engage with learning, to engage with content. And then later, they will get in touch with the math and all of that, but it's not a place that is stigmatized with, this is like a place where you go where you can't. So I think that's a fundamental difference with the shop class that is very important.
So there's a lot of talk about teaching creativity and teaching innovation, and I wonder if sometimes those are surrogates for giving choice or agency. How does a Fab Lab create opportunities for innovation and creativity, and are those valuable? We talk about them as being valuable, but are they truly needed right now?
You mean the innovation and creativity skills and all of that?
Correct.
Yeah, so I think, probably you had people talking in this program many times about how the job market is changing, how society is changing and all of that. So I don't want to kind of dwell on that, but just to say that the kinds of skills and abilities that we care about, they changed greatly in the last 30 years, right? So there is work from economists. You can look at, for example, Levy and Murnam's 2005 paper where they look at changes in the kinds of tasks that people do in the job market, and so they did research about what kinds of tasks are going down, what kind of tasks are going up, and basically everything that is routine, so either cognitively or manual tasks that are routine that can be replaced by a computer, by software, they are of course in less demand. But there are lots of things that are going up. So complex diagnosis of things, complex communication, expert thinking, and all of that. And so this is not just like, again, my opinion about things. There is research showing that the profile of the jobs and the kinds of tasks that people do is actually changing radically. Not only that, but the kinds of ways you add value to a company, to a process and all of that. It used to be that those things could take 20, 30 years, but now, you have one iPhone every year, you have one iPad every year, you have one, the product development cycle is a lot faster. The third thing is that the way that innovation happens in the companies is also different, because it used to be that, when you have 10 years to create a product, every engineer is doing a little piece of it, and so it's a much more like an assembly line of new products. But today, in a company, they have digital fabrication labs where they are creating, 2-3 prototypes every day, every week of new products. So if you go to work in this kind of places, you're not going to do one thing for 2 years. You're going to create prototypes. You're going to brainstorm a lot more. You're going to have a lot of opportunities to be creative, to think outside of the box and all of that. So the way engineers work is, fundamentally different as well. So, I think there is a lot of controversy about, is that actually true? Are we, is there a way to teach creativity? And I think some people are asking this in the chat here. But I think fundamentally, if you just take the, popular view, and which is also based on research, that you need 10,000 hours to become an expert. So imagine that you finish college at 22 or 21, and then you want to be an expert innovator, an expert creator of new processes, new products. So 10 years means that you have to do it for another 10 years or 10,000 hours to become an expert. But imagine if you can start that at 13 or 12. And so by the time you get out of college, you already had, 5,000 hours of being an innovator, being a creative thinker, being a creative generator of new ideas and all of that. So I think we can start that a lot earlier than, wait for people to finish college and then say, oh, by the way you learn all these things, by just repetition of old stuff and creating what's already out there, is not really the way you're going to work. So now we're going to retrain you to be creative, to be. So it's probably doesn't make much sense to start it that late. Not only that, but of course you're going to learn much better. You're going to be a lot happier in school if you have lots of opportunities to create, to innovate. And if you talk to teachers, I've had experience with teachers that, of course, sometimes in the beginning they are afraid and all of that, but after they went through these workshops that we do with kids in the fabrication lab, they say, oh my God, this is exactly why I came to the teaching profession. This is exactly why I wanted to be a teacher, because I wanted to feel kids engaged in this way. I wanted to feel them passionate about learning, passionate about what they were doing. And I hate this role of, being the kind of enforcers of rules and just reciting knowledge and all of that. So I think sometimes, people say about, okay, that's great, let's teach all this, innovation and creativity, but, teachers, a lot of teachers, they thrive in that environment. But of course we have to train them to do that. But that's exactly why they came for, why they became a teacher in the first place, to see that kind of impact in their kids' lives.
You tell a story in your TEDx talk about the elephants which are doing artwork but are actually controlled by somebody pulling on their ears. It's kind of an unforgettable story. How much of the choice right now is between control and student choice? Is that a fair way to frame the difference?
Yeah, I think, there is a lot of, many of you might have heard of this, all these new techniques to monitor what students are doing, especially like in online environments where you can, record every mouse click, and some of these environments where you have like these tests that you can do, and, you have to get 10 of them right and all of that. So there is a lot of movement of using new technologies to better control students, to monitor what they do. But there's no consideration of, is what they are doing the right thing to do? So it's like this obsession with control and monitoring and recording every mouse click. But, if you're doing recording mouse clicks and what kids are actually doing is a stupid task that's not really going anywhere, it doesn't matter if you have all the detail about what you're doing. So there is a danger with all the technologies that we have right now, for logging what people do and all kinds of things. So there is an end game of that, which is, we're going to have tons and tons, terabytes of data about students doing multiple choice tests, students answering very, very simple questions, everything that the technology is good enough to assess. And I think that's a terrible scenario because, computers are not very good at looking at open-ended answers. They're not very good at looking at a robot and telling if the robot is a good project or not. But they're great at, grading multiple choice tests. And there is a big danger of just education becoming more and more of that just because that's what the technology can do. And I see a lot of that in many of these online environments that people say, oh yeah, we can just do these silly tests. And I think that's a terrible thing. On the other hand, when we start going to the more open-ended, open choice kind of things, we need to develop a lot of new technologies to do assessment, not only like automated assessment, which we are doing sometimes, but also giving better technologies for teachers to monitor what's going on in a classroom. So when you have a project-based classroom, you need to know, where students are, if students are doing well, which project, where you should direct your help, and all of that. And we are developing a lot of those tools. So for example, we have a project that we do in the Intro to Programming course where we are, we have an automated algorithm that is able, to detect what we call sync states. So when kids are stuck in a particular state in their program, in their code, the system detects that. So then, maybe the teacher can go there and try to help them, or maybe they can get more help and all of that. So I think those are the interesting things. I mean, there is an interesting combination of free choice and this monitoring technologies, which is let's use the technology not to make it dumber and more oppressive and more kind of 1984-like, but let's give kids more freedom and develop this really high-end technologies that can help us see when they need help, human help, and then we go there and help them. And I think that makes it a lot more scalable and all of that. But I think there is definitely a choice there that we have to make, either by over-controlling or developing technologies to enable freedom.
John Seeley Brown talks about freedom within structure, and my guess is that that's probably close to a definition you would give for what takes place in a Fab Lab.
Choice within structure, yeah. So, just as I said in the beginning, when we tried the completely kind of anything goes open-ended, here's the lab, do whatever you want kind of approach, it works for 20% of the kids who are very, self-directed and all of that. But for the other ones, they need, scaffolding. They need some ideas to begin with. They need some starter projects. So we started to develop materials for that. So starter activities that we are, making all open source for our, partners and schools that want this material. So starter activities, some teacher guides to help teachers kind of facilitate those things. And those activities, they are increasingly, they start with something very small that they can do in a couple of hours, and then they grow in complexity and in choice, so that even kids who are not sure about what they can do, they can find themselves in this structure and thrive in those environments. Because something that we don't realize is that a lot of times you take a child that has been educated for 8-10 years in one kind of environment, and you just let them loose in a completely different place. It can be threatening. It can be difficult. So we need to scaffold that transition a little bit as well. So give some structure, but increasingly let go of a lot of the constraints and all of that, so that they can thrive in the more open-ended environment.
So there are a set of questions on the screen that were asked while we were waiting for you to arrive in the room, and then a couple have come in through the chat that I've put down as well. Let's start with the one, and then I'll let you choose some others that you'd like to address in the final 10 minutes. So Dan wants to know, is there any long-term tracking to see how participation in the lab affects learning habits later in their schooling?
Yes. So in one of the school, in some of the schools that we're working, we're collecting this longitudinal data. So these large-scale surveys and interviews and data collection things, where we every 3 months we collect a set of data about these kids. And because this is a 6 to 12 grade school in particular, we started this last year, so we'll have a lot of this data to track what they learn, their career choice, their STEM learning in particular, and all of that. So that's one of my main concerns of research, is to show that this approach works and it can be scalable and it has an impact on how kids learn. So we are, of course, we just have 1 year worth of data, but we are still collecting it, and soon we'll have a very interesting longitudinal portrait of what happens with those kids.
Are there any questions on the board that you would like to sort of quickly answer? Didn't really talk about low income yet. Do you want to take that second one there about how you connect with inner city kids?
Yeah, so just very quickly, I think again, one of my main concerns with a lot of like the kind of maker culture and maker fair and the Fab Labs and all of those things is that there is a scenario where we would benefit disproportionately the kids who are already privileged, and because, as I said, you put them in a space, and if they don't have any background on what to do, if they don't have the right support, they might just not thrive in that space, as opposed to the kids who are already come from a privileged background. Their parents are engineers, they're not afraid of anything. And so there is a scenario where we'll just make the gap increase by offering those kinds of opportunities. So I think it's very important to be careful about the equality and diversity aspect. So one of the things I'll try to summarize it very quickly is, so in one of the surveys, this data collection things we did, we asked kids, do you like inventing things? Do you like inventing things? And so we were comparing two schools, a low income school and a high income school. The kids from the high income school were twice as likely to say, I like inventing things, than the kids in the low income school. Then we asked another question, and when you see something broken, do you think about fixing it? And then it's exactly the opposite. The kids from the low-income school, they are twice as likely to say, yes, I think about fixing it, than the kids from the high-income school. So, of course, I'm simplifying a lot of, there are many more questions in this thing, but the general picture is that the kids from the high-income schools, they are already, biased towards being interested in a lot of those things. And the kids from the low-income schools, sometimes they feel that what they do is not really socially valued, is not important. What they do is not creating. They're just fixing stuff. And I saw that in Brazil a lot when we were in public schools, and we asked kids, are you good with technology? And they said, no, we don't have any technology. We're poor, right? Then I went to observe what they had in their houses and in their like playground and all of that, and they had this like washing machines that they repurposed as a TV antenna, or this kitchen appliances that became toys and all of that. And it was technically very complicated to do those kinds of repurposing and adaptations, but they didn't see that as technology. They saw that as something that poor kids have to do because they don't have any toys, as opposed to the rich kids who actually sometimes did nice Lego robots, but were far less sophisticated than the repurposed toys, the repurposed electronics that the kids did. So what we did in this workshop in Brazil, and there is a paper about that. People can search. It's called Travels in Troy with Freire. It's on my website. Was that we said, okay, now you have all these repurposed toys. We're going to teach you how to add robotics to it. So we taught the kids from the slums in São Paulo to add motors and microcontrollers and sensors to their repurposed toys and devices and all of that. And then all of a sudden they realize, oh, what we are doing is technology, and it's, sophisticated, and it's actually much better than the Lego stuff that the kids, across the highway are doing. And that was so empowering and amazing for those kids, because they suddenly realized that, yeah, they have a lot of technological expertise. Technology is not about expensive stuff you buy in a store. It's about, a skill you have and knowledge you have. So, when I talk about low-income kids, I always depart from this perspective, and which is a Freirean perspective, which is, let's find out how people do technology in their local communities, in their local cultures. And there's always a way that they use technology. Sometimes it's not the way we look at technology, like it's not that they have iPads and they are downloading apps, but they are always doing sophisticated technological stuff, repurposing, reinventing, re-engineering different things. And so the first thing that I do when I go work with a new community is to find out about that, about how they do technology. And then I add on to that, some new technologies like robotics, microcontrollers, and things like that, and digital fabrication. I never say, look, you're poor kids, you know nothing, and you have all this and come to my fancy lab, because that doesn't work, and that, of course, does exactly the opposite. So I always depart from their perspective and their use of technology, and then we add on, new things that are socially valued, and that will highlight what they do already. So I think that's, an important aspect of this issue that you're asking.
So there are two questions that are somewhat related. One is the cost of a fab lab, and the other is, how does this spread? So is this expensive to do, and how are you hoping that this will spread to other areas in other ways?
Yeah, so before I forget, we are doing a conference on digital fabrication for education in October at Stanford. It's a conference called Fab Learn 2012. Fab Learn 2012. It's on on my website, but later we can send the link to everyone. And we have a call for a proposal. So if you want to present a paper or a demo or an experience, you can send as a proposal, or you can just come and attend the conference later. Anyways. The cost of a fab lab, it varies a little bit, but I would say, a very, very basic setup would cost around $10,000, I would say, and it goes all the way up to 50 or 60. I wouldn't, people say, oh God, this is too expensive to be relevant, it's $50,000. But the thing is, in 5 years, this will be $20,000, and then 10. It's going to cost less, in 2 years, it's going to cost less than a laptop cart, for sure. So the cost issue will be less and less relevant. Now, when I first started this, we bought, the laser cutter was $20,000. Now, just like 2 months ago, we bought a Chinese laser cutter for $3,000. It's not as perfect as the other one, but it works fine. And the difference between having a room that's empty and a room that has a $3,000 laser cutter is incredible. So, if you have 10,000, you can start something simple and then go from there. So I think the cost should not scare anyone, because the cost of the equipment, because it's not really, it's going to go down. What really is more, costly and more resource intensive is training the teachers and having good people in the school that can lead this kind of initiatives. So every time we work with a school, we say, we need a real, a leader in the school that will, carry this forward. And so I think the greatest cost in a way is the professional development, more than the equipment. And it's kind of unfortunate that people get kind of caught on the equipment side, but the professional development is more, not just cost in terms of money, but just in terms of time. But it pays off a lot, because, when you have capable people that can do. I mean, the results are just so obvious that it kind of it generates a very interesting movement in the school. And I think some people asked about how I'm helping teachers integrate the technology and all of that. So we're designing many different things. One of them is called bifocal modeling. So you can also see on my website. So this is a way, an approach that we designed to integrate science class and digital fabrication. I don't have time, of course, I think we're almost done, but to explain in detail. But one of the fundamental points is not to make these fabrication labs an after-school program. And I see that so many times, and I think it's exactly the wrong way to do it. If you only do after-school programs, you only get the same self-selected kind of kids that you always get. And so it's important to integrate them into the regular classroom. We've done this in history, in the history class, in science, in math, in art, and it really works well. And I think the idea is, if you like sports in a school, you go to the gym, right? If you like reading, you go to the library. If you like music, you go to the music room. But if you like invention and creation, you have nowhere to go. There's no community. There's no culture around that. So, and people say, why do you need a lab? I mean, that's the same reason you need a gym or you need a music room, is because it becomes a culture-building place in the school. And it's very hard to get rid of this room, because when I've done so many robotics workshops in schools, and the sad thing is that once it's over, kids don't have a place, a physical space to carry on the work, and it just has no place in the school. When you have a room where it's a dedicated room for that, a lot of magical things happen, because it becomes part of the school culture.
So I've put your web page up, and I put a link in the chat. It does have contact information for you. And we do, as a courtesy to our guests, we try and finish on time, and so I'm clapping for you. In the participant window, I hover over the smiley face, and I go down to applause. I can't tell you how much I appreciate your coming on the show and getting to know you a little bit better. I think there are a lot of us who are going to find that your voice is really helpful in this regard, and I'm somewhat stunned by the Freire-Papert connection, and hope that we're going to have additional opportunities. If you'd like to put the link to the conference in the chat, please feel free to do so at this time, and because I think there are many who'd be interested in that. So thanks to Paulo for coming on tonight. Terrific. Really, really a fun show. Don't miss next week's Learning 2.0 conference with all kinds of great stuff going on. That's at learning20.com. Paulo, thanks a lot.
Thanks a lot, Steve. I put the links, and also if people want the paper about Freire and Papert, it's called Travels in Troy Freire. You can Google it or just look on my website. And email me if you have any questions. It was a great opportunity, and I hope to keep the conversation going. And thanks a lot for the great questions. We couldn't get to all of them, but eventually we'll email and be able to talk more. Thanks a lot, Steve, and everyone.
Thanks, Paulo. Thanks, everybody. Terrific show. Really appreciate it. Again, the schedule of upcoming events is on your screen. And the Learning 2.0 conference is at learning20.com. Take care, everybody. Good night or good day to those of you in Australia and New Zealand.